Okay, so the question number 7, we are going to look into the question number 7. Transport inspectors carry out roadside safety tests on lorries. Part A, the probability of a randomly selected lorry failing the test is 0.25. A transport inspector chooses 2 lorries at random. Find the probability that both will fail the test. Exactly one will pass the test. Solve this one in 2 different ways. Number 1, you can use binomial probability distribution. Reason is, this is the probability of failing. Failing, not failing. You can consider failing as success and not failing as failure. That means P as 0.25, Q as 1 minus 0.25, which is 0.75. Reason is, for binomial probability, P plus Q is 1. Okay, now again, if not, both will fail the test. Look at, first lorry failing the test will not affect the second lorry to fail the test. So, okay, both will fail the test. Then both will fail means first lorry failing the test will not affect the second lorry to fail the test. So, you can treat these two trials as independent events. So, independent events, how to get this one? P first fail and second fail, that means P fail into P fail. The reason is, you can treat this one as independent events because first lorry failing the test will not affect the second lorry to fail the test. So therefore this one is 0.25 and this is again 0.25. So the final answer, you can get it from that 0.0625. Okay, that is the answer for this one. Okay, now if we are using binomial probability distribution, how we can do this one? Now look at total number of lorries 2. That means n is equal to 2. And out of that 2, you select 2. That means the success rate is also 2. 2 become fail. Okay, now if you get this equation mentioned in red, x is equal to 2, then 2, 2. This is NCX, that means 2C2. This is 1. Okay, 2 is 1. And this one is 0.25 to the power 2. And this one is 0.75 to the power 0. Why? N minus x, n is 2, x is 2, so n minus x is 0. So this one will give you 0.0625, the same answer as this. Okay, that is how we get the answer for the first question. Okay, let's move into the next question. Exactly one will pass the test. Exactly one will pass the test means probability first one pass the test, first pass the test, second fails, and first fails, second pass. You have to consider both, right? So if we get again this fast fail, first passing and second failing, this one is again independent, right? Sorry, the other way around. 0.75 into 0.25 plus 0.25 into 0.75. So 2 times 0.75 into 0.25. So you can get the answer for this one, 0.3 0.75. Right? What if you are going to use the binomial probability distribution for this one? Now asking just one will pass the test. That means success is 1. One will pass the test. Here you can consider P as 0.75, Q as 0.25. Based on the question, you decide which is success, which is failure. Now asking at exactly one will pass the test. So probability x is equal to 1. Then 2, 1. Success is 0.75 times 1 into 0.25 times 1. So 2C1, this one is 2C1, so that is 2. 2C1 is 2. Then 0.75 into 0.25, 0.375. Okay, so that is how you can get the answer from the binomial probability distribution. Okay, of 12 lorries parked outside a transport cafe, 4 would fail if tested. Okay, you can find out probability of fail as 4 divided by 12 or 1 over 3. Now this case is different than the previous because out of 12, 4 would fail the test. Okay, and P pass, you can say success, P pass is the remaining. That means 2 divided by 3. That means 2 divided by 3. Or you can say it is 8 divided by 12. If 4 passes, if 4 fails, 8 passes. So this one will be 2 divided by 3. Except that one, how to get this? P fail plus P pass should equal to 1. In that way also you can think about that. Okay, an inspector chooses 2 of these 12 lorries at random. Find the probability that both will pass the test. Both will pass the test. That means P pass. Then here first pass the test, that is 8 divided by 12 into second pass the test, 7 divided by 11. Why? Because we are not going to replace that passed lorry into this 12 lorries again. So the sample size is getting decreased by 1. So you can get the answer from this. Both pass the test. An inspector chooses 3 of these lorries at random. Find the probability that 2 will pass the test and 1 will fail the test. You have to consider 3 type of things if you are working on this type of format. What is that? Probability fail, pass, plus probability pass, fail, pass, plus probability pass, fail. This is the scenario. But for this one, you can get the answer from this one actually. But the most easiest way to do this one with these combinations. Anyhow, you cannot use the binomial probability here. The reason is trials are not independent to use the binomial probability distribution. 3, 1 times, everything is same. Failing is 4 divided by 12. Then passing the second is 8 divided by 11. Then 7 divided by 10. Got it? One by one reducing, right? So this one will be 3 times 4 into 8 into 7 divided by 12 into 11 into 10. So you can get the answer by simplifying this one. It will be 28 divided by 55. Okay. An inspector chooses 4 of these lorries at random. Find the probability that at least one will fail the test. At least one will fail the test. Okay, this is kind of tricky question. Okay, first of all, an inspector chooses 4 of these lorries at random. Find the probability that at least one will fail the test. At least one means there can be more than one failures. That means 2 failures, 3 failures, all failure case. This one, even in binomial probability distribution, think that binomial random variable has a maximum of n. Then x value is starting from 0, 1, 2 and then until n, right? For this one, probability of x is equal to 0 plus probability of x greater than or equal to 1. This one and this entire thing should equal to 1. This is the rule in binomial probability. Okay, so same as that, for x greater than or equal to 1, you can consider as 1 minus probability x is equal to 0, right, from this. If I explain further, you can consider probability x less than or equal to 2 plus probability x greater than or equal to 3 as 1. Right? What is the reason? Because for everything here, okay, let's see, write 3 here. Below 2, including 2, below 2 plus above 3, including 3, should sum up to 1 based on the binomial probability. Okay, the same concept you can apply here. You can apply this here. Probability of x greater than or equal to 1. At least one failing is equal to 1 minus nothing fails. 1 minus nothing fails. Nothing fails means all passes, right? Okay, then this is 1 minus. If the first one passes, what is the probability? 8 divided by 12. Then second passes 7 divided by 11. Third passes 6 divided by 10. And then fourth passes 5 divided by 9. Simplify this one. This will give you 1 minus 0.1414. So the final answer is 0.8586. Okay, that's all for this question. Have a good day.